In this video, we are going to look at the elimination method to solving linear equations. So let's say you're given two equations just like this, and you want to find the solution, which basically means you could graph them and see where they intersect. And in this problem, it would be 2, 4. But what if you don't want to graph them? Or what happens if you graph them and you get a line like this and a line like this, and they intersect somewhere funky that's not like in the corner of one of the boxes, so you can just count. So that's why we want to do this algebraically. And sometimes they flat out ask you to use the elimination method on a test or something like that. So, like I was saying, you could solve these for y and graph and see where they intersect. Or we could do the elimination method. That's what we're going to do in this problem. So, elimination sounds exactly what it is. We're going to eliminate one of the variables because you can't solve just one equation that has two variables. You just can't do it. You don't have enough information. So let's eliminate x in this problem. The object of elimination is to get one of your variables the exact opposite of the other variable. And notice how I already did that here. 4x and negative 4x are opposites. So I'm ready to just add these two equations together. Once you have a variable that's the exact opposite of the other, you just add the equations together. So I'm going to add straight up and down. 4x and negative 4x are eliminated. That gets you 0. And then negative 5y and 8y get you 3y. And 10 minus 4 is 6. And notice how now we have an equation that we can solve quite easily. 3y equals 6. Divide both sides by 3, and you get y equals 2. Now, don't forget, 2 is always your second coordinate because it's y. So when you say your answer, you need to give an ordered pair, which is x comma y. So 2 is your y coordinate, and you can plug the y back into either equation to get the x coordinate. So 4x minus 5y, which we know is 2, equals 10. So 4x minus 10 equals 10, and I'm going to add 10 to both sides. 4x equals 20, and then divide both sides by 4, and you get x equals 5. And just like that, without having to graph stuff, which would be kind of annoying, we have our answer, 5 comma 2. So not that bad, right? In this example, notice how we don't have a variable that's the exact opposite of the other variable. That's what we need to do. We need to get one of the variables to be the exact opposite of the other. And I'm going to decide to eliminate x. So I'm going to multiply this bottom equation by negative 3. That way I have a 3x and a negative 3x, and I can add straight up and down, and the x's will be eliminated. So I'm just carrying down the first equation. And then I'm going to carry down the second equation, but I'm multiplying everything by negative 3. And now I can just add my two equations together. 3x and negative 3x gets me 0. They're eliminated. And then 5y and 6y get me 11. Then negative 7 and negative 15. Don't forget you're adding. So negative 7 plus negative 15 is negative 22. And y is just negative 2. Now in the first two examples, I did eliminate x in both of them. But if it's easier, you can eliminate y. So y is negative 2, and then I plug it back in. I'm going to plug it into the easier one. So x minus 2y, so 2 times negative 2, equals 5. Those negatives cancel, and I'll do it up here. X plus 4 equals 5, and x equals 1. And that's my answer, 1 comma negative 2. Now, if you want to check your answer, what you can do is you can plug your x coordinate into x, your y coordinate into y, into both of these equations. Either one, it should work. And that's how you can check. So 3 times x, so 3 times 1, that's 3. 5 times negative 2, that's negative 10. And yes, 3 minus 10 gives us negative 7. And you could try that in the bottom equation as well, but 1 plus 4 does give you 5 as well. Last example, and this one's a little different because I set it up a little more difficultly for you guys. So We want to get your x's lined up, your y's lined up, and your constants lined up on the other side of the equal sign. So let's do that. In the top equation, I'm going to first subtract 4y on both sides, and I'll get 7x minus 4y equals 18. And notice how in the second equation, the y is first and the x is second. So I'm just going to reverse that. So negative 5x I'll put first, plus 3y equals negative 14. And another reason this problem is a little more difficult is because there's nothing you can just multiply one of the equations by, or at least not an integer, where we'll be able to eliminate a variable. So considering I eliminated x in both of those first examples, I'm going to, just for funsies, eliminate y. So something I can do is I can multiply the top equation by 3. So I will multiply this guy, both sides, by 3. And then this guy, well, I'll have a negative 12y here. So I need a positive 12y on the bottom equation. Multiply both sides by 4. Now, once I do that, I will have 21x minus 12y equals 8 times 3, which is 54 on the top. And then the bottom equation, when I multiply everything by negative 4, or positive 4, excuse me, we'll have negative 20x plus 12y, and yes, the y's are going to eliminate just perfectly, and that's going to equal negative 56, 14 times 4. Cool. And then I can just add those together. The y's cancel, and look how nicely that is. I'll just get x equals negative 2, and x is already solved for, which is great. It happened to work out that way. So my answer will be negative 2 comma something. And I am going to plug negative 2 in for x into one of these equations. It really doesn't matter. I have like 6 equations I could plug this into. I'm going to plug it into the very, very, very top one. So 7 times negative 2 is negative 14, and that will equal 4y plus 18. Subtract 18 to both sides, and I get negative 32 equals 4y, excuse me. And then y equals 8. And just to check, you can plug this back into the original equations. So let's do that. Why not? 7 times negative 2 is negative 14. And then we get 4y plus 18, which is incorrect. 4y is 32, plus 18 is 50. So we know we did something wrong here. And the thing we did wrong here must have been for getting this negative sign right here. So you always want to check your work, guys. Now we can try it. 7 times negative 2 is negative 14. And then 4 times negative 8 is negative 32 plus 18, and that gets us to that negative 14. So it's nice to check your work, and I'm going to be honest, I did not mean to make that mistake. I just genuinely forgot a negative sign from right there when I divided negative 32 by 4. Cool. And then in the other equation, 3 times negative 8 is negative 24 plus 5 times 2 when the negatives cancel, and that gets you your negative 14. So guys, make sure to check your work. You can see how easily you can make a mistake here. So that's all I got. Make sure to like and subscribe if you are comfortable with substitution now. It'll really help me out, but I will see you guys in the next video.
Brad does math.